Thanks to the guys for organising the event, and glad to be participating here today. So Gooee has evolved as a technology company over the years, and it's really compelling to stand here today and see how lighting's position in the intelligent buildings has evolved. We started this journey sort of 5 years ago with an idea that lighting could do more than stop you falling over in the dark. And here we are today with the majority of the conversations and talks been around lighting as this smart infrastructure and what it can really deliver within a building. And so what I wanted to sort of talk about today is how that sort of has evolved for us and how we started with lighting, because it was kind of in our heritage and what we knew, and we believe it to be the most sort of important pervasive infrastructure element in buildings, and it's one that is constantly being replaced. So the opportunity to integrate technology into that device is very valid. So we'll walk through sort of some of the journey of how we got to where we are and lighting's part in it here today. So if we step back and sort of look at the bigger picture, how we started seeing life, fundamentally we recognized that buildings were not adapting to the environments within which we exist today. That's both environmental, rising populations, rising environmental conditions, air quality problems. And a lot of these buildings are, I think at the last count, sort of 35% of the buildings are over 50 years old. And so there's a lot of old stock of buildings out there. And with this change in population and change in how we work in buildings just weren't being very equipped to deal with how life was changing for us. So when we looked at the challenges that we saw within the built space, there were many. And some of the statistics about buildings and how they contribute to the environment were quite astonishing. But fundamentally, we started looking at the systems that existed within buildings and realized that there were so many siloed systems in a building. Many of them were installed and designed to function. They weren't necessarily designed for efficiency. Many of them weren't connected either to some kind of remote management center or even connected to each other. And so the cost of integration at a custom level and sort of getting a building to talk and respond to itself was a challenge. And so I think one of the most shocking statistics for me was that buildings globally contribute to 40% of our global energy demand and 40% of our global CO2 production. And so you sort of think to yourself, well, if we've got a way to use technology and bring things together and manage these buildings better, then we can have a massive global impact on energy and carbon. And lighting plays a significant part of that, circa 19%. LEDs help that reduce down, and better control of lighting will further that benefit. We see this old amount of buildings, 35% over 50 years old, about 20% are over 70 years old. And so implementing technology in these old infrastructures is inherently difficult. And so wired technologies existing in these buildings prove problematic for adding new infrastructure, smart sensors and technology. And that leads to a lot of inefficiencies around how buildings are contracted, how maintenance contracts are put in place, cleaning contracts. People take on management of buildings with less and less information about what's really going on inside that building. Low margin businesses struggle to maintain and manage aging infrastructure in buildings. And you've got a massive underutilization of space. Statistics tell us that on average half of the general office space globally is just not being utilized properly. And this whole sort of lack of access to data means, you can't manage what you can't measure. There's a lot of sort of hiding behind the problem. If we can't see it, we pay our energy bills, we pay our maintenance bills. Nothing changes, there's nothing we can do about it. But, fundamentally, we believe through lighting, through integration of technology and solutions, that there is a different way to do it. So we believe there's time for change. We believe that looking at not just how we do things going forward in new buildings, but how we deal with the massive existing stock of buildings that are out there. I think in the UK, 70% of all the buildings we need till 2050 are already in existence. And so the retrofit market is much larger. And so trying to get back and deal with what we have, as well as dealing with how we do things differently going forward, is something we take a lot of time thinking about. And then working on how we can lower this sort of massive energy demand and CO2 footprint, increasing general sustainability across a building, just making buildings generally a better place to be. You know, I heard a statistic the other day that, you know, in New York, in the middle of summer, with all the air conditioning running in the buildings and the pollution, the temperature on a sidewalk can get up to sort of 60, 65 degrees centigrade. And a lot of that's contributed from hot air being pushed out of buildings. I mean, countries like Singapore, Hong Kong now, you have glass-covered walkways in streets because the environments are so polluted and congested with cars, people, and what buildings are trying to do to cope with the changing in the environment. And there's a lot more focus, not just on the buildings, but the people who live within them. We're spending more time at work, and so making that place a better place to be and focusing on the well-being of people is another important element in sort of making this change happen. And for property owners, you know, they're looking at their yield. Their yield is a function of how much money they're getting in and how much money they're paying out, how occupied that building is, and then sort of the general profitability of that building over time. And so thinking about how technology can help improve yield for property owners so that there's an investment in technology to make it a better place to be for the tenants, but also a financial benefit for them. So technology itself can have a massive impact on this yield, this running cost of a building, whether you're a landlord and tenant or whether you're a building owner. When we look at the total running costs or the ownership costs of a building over its lifetime, 80% of the costs of a building come from its management, its maintenance over time. And so if we turn our attention to that from a technology perspective, with just a 2% increase in investment in technology at the construction phase, you can have a massive impact in reducing the running costs of that building over time. So we're not just thinking about sort of, you know, going into new buildings and retrofitting, we're thinking about how it's been developed from the beginning, but applying the principles on both sides of the table, looking at reducing that consumption of energy, improving the maintenance, decreasing the maintenance, squeezing the asset, as they call it in the industry. That's the assets that are in the building. If they're using less energy, then they last longer, so they cost less to maintain. And if the whole building itself is costing less to run and maintain, then that asset is more valuable to whoever owns it over time. And about 95% of all buildings globally are owned as assets, and it is the largest asset class in the world. So we sort of evolved from looking at lighting as a host for technology to then looking at the space within the buildings itself, and then to looking at holistically at the whole building and trying to produce an operating platform, as we call it, and connecting the devices within the building through lighting, sensing, hard infrastructure, the heating and cooling systems in there, and bring this building to life and make it a much more adaptive and responsive environment to what's going on inside the building, i.e. the occupancy, and what's going on outside the building, to become the sort of eyes, ears, and brain of a building effectively. So we like to sort of think of ourselves of bringing buildings to life, taking these static, monolithic structures that were commissioned and scheduled to be perfect at one point in a year when they were initially commissioned, and schedules run in a building, but conditions change, environments change, usage changes. And so we sort of started to approach buildings and all the various systems to say, well, you know, Android did a very good job in the marketplace of creating a very open platform, software that could work with any hardware and try and tie it all together. And so Gooee's been sort of likened to the Android of building operating systems. We're very open, we're very hardware agnostic. We want to work with any technology that's in the building today, but also any technology that can come into the building tomorrow. So we're about connecting that infrastructure that exists in the building, connecting the service propositions that are and the contracts in that building, and connecting the data and putting that data together and creating access to it so that you can do better things with it. You can drive efficiency, you can understand how much space you really need in the building, and trying to create something that's scalable. You know, with enough time and money, anything's possible in a small building or even a large one, but how can we create something that can be deployed globally and can be used to improve buildings and make them more efficient globally. And create access to data in real time. Typically in the built space, if you can get access to data in these silos, it's usually day plus one. And so getting access to data to do things in real time operationally, take data from sensors and drive the heating and cooling system to do what it needs to do dynamically versus on a schedule, can drive massive improvements, not just to the bottom line, but to the environment that you exist in. And if you know what's going on in a building, you can predict much more reliably what's going to fail, when you need to maintain that building. And we look a lot at call-outs in buildings and the inefficiencies of people driving to buildings with false alarms, when if you can remotely look at that building, you can monitor and manage it better. And that all leads to increased sustainability, corporate social responsibility, and ESG, which a lot of companies and property owners are focused heavily on making sure they're complying with CSR and ESG directives. But as a platform and as a business, we sort of see ourselves existing in an ecosystem. And there's a lot of these words banded around, what's a platform, what is an ecosystem? But the way we think about it is, a platform, and you can have multiple platforms within an ecosystem. Its job is to try and create value on multiple sides of the coin. And so if we were going into a space just targeting property owners, but that was at the detriment of the tenant, then it wasn't going to work. So we think a lot about how from the construction phase into owning buildings and to maintaining them. On the left-hand side, we can provide value across the board to anyone who uses the solution. And then on the right-hand side, to the people who inhabit these buildings, the tenants, the employees, the customers within a retail space. How can you improve their experience in a building? And then looking at the channel partners, the people who actually go and do the work and exist to maintain in these buildings, providing them new technology, better, more efficient ways to increase their margins and provide new services. And then we look at the technology providers that are out there, many of whom are here today. And Gooee wants to open itself up to allow whatever is the right technology from a hardware perspective or even software to exist within the building. We want to be that glue to put it all together. And we've had to develop certain elements of our solution to make that happen, but ultimately long-term, Gooee is more about providing a network technology through lighting, and it's about the data business and providing access to that data. So the value propositions for a smarter building as we see it is to sort of discover everything that's in the building. That's any sort of hard connected device that draws power or is connected to a BMS, be it lighting, heating, cooling, refrigeration. And our job is to sort of integrate all that together and sort of try and bring it together in a single pane view, as we'll call it, in a way that you can now bidirectionally control those devices. And then look at three key things. We're looking at how that building's serviced and maintained, trying to provide a remote two-way control of the building, improving that service. It takes around 7 phone calls to get anything fixed in a building today. And the amount of inefficiencies driving back and forth the maintenance companies into buildings to try and just even find where the problem is. 60% of buildings today don't even have plans as to where things are in the buildings. A lot of information residing in building managers' heads. And so trying to digitize buildings, try and demonstrate what's there and provide access to it, to try and just provide a better maintenance and service element. And do a lot of stuff remotely. So when we look at a building and we look at the typical call-outs, you can break it down into 3 main categories. A lot of false alarms where you didn't ever need to go to that building. You can look at heating and cooling requests. So probably the number one reason maintenance companies get called out. I'm too hot, I'm too cold, the heating's not working, the building's too hot. And so being able to effectively manage that remotely saves a lot of the call-outs. And then if somebody does have to go to a building, they should go there knowing what they need to do, knowing what they need to fix, and with the right expertise in that building. So that's the sort of the service proposition. And then when we look at sustainability, it's about then using algorithms and technology to take those devices and make them run more efficiently, make them last longer. Look at how we can predict what the energy consumption will be going forward. And we can simulate usage in that building, change of usage. We can look at, by improving your lighting or changing your heating and cooling system, what effect that will have, what will be the return on that. And that's all about using data and simulating based on historical, real-time, and predicting the future. And then looking at how that impacts in terms of carbon reduction and management. And then the last element being well-being. It's the slightly more intangible, subjective element, but it's one that's probably of the most importance going forward. So JLL, famously a few years ago, came out with a rule of thumb. They called it the 330-300 rule. And what it was trying to demonstrate was that globally for JLL, they found that on average people were paying $3 per square foot for their energy, $30 per square foot for their space, and $300 per square foot to put people in it. And that's the cost of people, sickness, productivity. The general sentiment was people are 100 times more costly than your energy bills, and then 90% of a typical business's overhead. And so looking after the people in the building, making them more productive, giving them better lighting, giving them more access into the building in terms of heating and cooling and personalizing their space, providing better air quality into that space is a very big growth area for any tenant trying to retain and attract people into buildings today. So how do we do it? So we break it into 3 key steps. The first is we'll come in to a building and we'll discover what's there. We call that a connect phase. We put a gateway into a building, and that gateway will basically, in a very non-invasive way, will sniff out what's connected into the network through the building management system and what's there. And we create almost a digital twin of that building, and we present that visually. So we take a whole bunch of data and we show people what that building looks like on a floor by floor, room by room, estate by estate level. And at that point, you then start to work with customers to find out what are they trying to achieve: better service, better sustainability, or a better place to be. And that's when we go into sort of the stage 2, where we provide full two-way control of any device: heating, lighting, cooling, refrigeration in that building. And we start to connect them together. And at that point, you haven't really added anything to the building. You've added physical gateway, you've added remote intelligence, we're providing engineering services remotely, and we're providing data and access to that data in a cloud platform with an open API. And then the next stage is to add smart infrastructure. And that's where lighting's role really plays the biggest element in this because of its pervasiveness. It's everywhere in a building. So we start with the concept of installing a smart Bluetooth mesh into buildings at scale. And we started working with the Bluetooth Special Interest Group and Nordic Semiconductor 4 years ago to try and create the best version, the best application of Bluetooth for buildings, for lighting control and sensing at scale. And so we do that with a product called Mesh View. It's like installing sort of Wi-Fi repeaters in a building. And you install these in the building, and that gives you the foundations to start capturing data using Bluetooth technology. And that's when you can start adding devices, smart lights, smart sensors into the building, reducing the need for wiring back to a central control unit, and start to build up this IoT network infrastructure in smart buildings, using lighting as that main host. And as I mentioned earlier, the great thing about lighting is it does fail. Over the years, lighting companies have had to go from things failing every 500 hours to failing every 5 years, but nevertheless, they do fail. And so there is always a point in time where you can replace that infrastructure. And if it's just got power to it, and we can integrate lighting and technology, communication, sensing into that light at that point, it's perfectly placed. It's got a perfect view of spaces. So it's a great place to put sensing, and it's always got power. And so it's got a lot of benefits to us to use as a host for technology. And that then motivates other companies who make smart sensors, smart control devices to say, well, there's now a real network in buildings that we can hang off. There's enough devices to make that network reliable and stable. So a lot of these technologies are sort of easy to talk about, but the hard bit's deploying them. So when we started this journey 5 years ago, we spent a lot of time and effort building the foundation for something that was very scalable, building an end-to-end solution. What we heard from the market is as we developed various components, smart lighting, smart sensing, a smart platform, that really people were looking for ownership. They were looking for a company to sort of take ownership for a piece of this, to take responsibility for the security of the data. So we got TÜV approval for IoT privacy and certification. They wanted a secure network, so we created the best, most secure version of moving Bluetooth information around buildings. And they wanted, a partner, a platform from which they could access this data reliably. And so we were fortunate that through the over 70 pilots that we've done in probably 10 countries, we started to identify some of these real needs, and we ended up where we are today, fully commercializing the solution only in April this year and starting to go to market. And a couple of the key customers that we've been working with, one, Kroon, Multer and Dross, are a facilities and management company in the Netherlands. And like any maintenance and engineering company, they're taking on contracts in buildings with more and more challenges, aging assets, and want to get control of buildings to provide a better service and to reduce their operational costs and provide new value-added services that they may otherwise not. The other thing with maintenance companies is that as they reach capacity with the number of men on the road, if they can reduce the time they're going to call-outs, they can increase their market share by taking on more contracts more reliably. The other company we work with is a major bank, and for them it's very common within banking to have these sort of large estates, these large buildings, but they didn't really know how the space was being used. So using space utilization technology, we're able to demonstrate that the real use of meeting rooms was just above 10%. And, when they get a lot of negative feedback from their staff saying they need bigger meeting rooms or this or that, the other, the reality was they just had the wrong type of meeting rooms. And so it's working with them to sort of provide that real objective data so they can make better decisions. And then working with a global technology company, one of the largest owners of real estate globally, to try and see how this lighting network within their buildings can be approved to be a secure device. A lot of concerns around IoT start with security. And so that's why, as I mentioned, we decided 2017 to get approval from TÜV. We were the first platform to attain that approval, which means that as a business, we take security and access to that security very, very seriously, and we're audited regularly on that. But it goes right down to a device level. And so particularly tech companies who are working in data are held to a higher account typically because of who they are. And so getting our devices approved to be in those infrastructures is a big step forward and a big validation for IoT and general smart lighting as a whole. And so they're looking at using it for both validation of hardware and technology in the solution, working with the beacon technology. Each light we have emits a beacon signal under Eddystone or iBeacon, and so they're looking at using the beacon network in lighting to do occupancy, to do wayfinding, indoor positioning, and other applications as well. So part of the challenge with any technology is scale. The problem is big. The opportunity to get control of commercial real estate globally represents a sort of, just between the US and Europe, a 12 billion square meter addressable market, just in commercial and retail space alone. And if you believe the statistics, they tell us 25 to 30% of that will become smart. And that means a lot of things to different people, but what it does tell us is that there is a massive sentiment. Over 86% of building managers want to use technology now to try and get access to their buildings and believe it's the way forward, but are just really struggling with it. We've also got sort of legislation in the macro market. We've got things like the Net Carbon Zero Initiative. The UK was the first government to sign up to achieve that by 2050, stating all buildings have to be net carbon zero by 2050. And there's also milestones along the way in 2030. In Europe, there are regulations like C23, which basically means that in the Netherlands, for example, a building has to be rated at C or above for energy, or you can't rent it from 2023. So there's a massive sort of sentiment of getting these buildings under control, otherwise, you're not going to be able to occupy them. And I mentioned about buildings as an asset. They are the biggest global asset. If you combined every other asset class, gold, etc., and you rolled them all up, they still wouldn't be as big as buildings. Including residential, it represents over $200 trillion of assets, but commercial real estate itself is around just over $32 trillion. And it's one of the only assets globally that's growing at such a high rate because we need more buildings, there's more people. And the population's rising exponentially as well. So it's a problem that's not going away, and trying to find technology to deal with that at scale is how we're trying to approach it. And we're not saying we're 100% there yet. We try to build the foundations to build something that is truly scalable to deal with this problem. And now's a very opportune time. We're getting sort of global pressure of greener, cleaner buildings and places to be in, the environmental pressure. There's this need for something that's scalable and also independently accessible. You know, we create access to data, we create access to the technologies in the buildings. The Gooee, the sticky thing that brings things together is what we try and stand for. There's rising costs, everything's getting more expensive, utilities, maintenance, rent, and so getting these things under control is important. But none of this was really possible 5 years ago. None of it was possible 2 years ago. If it weren't for the advancements in Bluetooth and how they looked at things and the developments of the mesh technology, and then how we were able to build on top of that, we wouldn't be able to provide a lighting network. We weren't able to demonstrate scalability through Zigbee. Wi-Fi doesn't mesh like the way we need to, and the IoT needs a low-powered network to exist. You know, you're not easily going to be putting Wi-Fi stickers and Zigbee stickers on assets to track them, but Bluetooth offers such a range of power technologies to use and integrations, and fundamentally, you know, we're all part of a network now with our handheld devices. They all have Bluetooth, and so having access to a network in lighting that can provide that connectivity is what Bluetooth brought to the table. And as we look forward, a lot of people say, well, aren't you scared of 5G, and isn't that going to replace it? The answer is no. I think they're complementary. You know, I think lighting is the future indoor cellular network, if you like, and all the 5G, 4G, 6G networks that will start to evolve and decline outside. It's our job to try and connect the two, so you can truly get an end-to-end wireless connectivity from your you know, smart watch right through to a cloud without going through any wired or Wi-Fi network. And so these are the things that we look forward to in terms of connectivity. And fundamentally, the cloud computing technology 5-6 years ago wasn't even capable of coping with the volume of devices. The IoT poses a very different problem to big data. It's a lot of small data, and that's got its own challenges. It's thousands, millions of things pushing lots of small bits of data up into the cloud. And so we started with Bluetooth because it was the best way we found to control how that data moves effectively and securely right up to the cloud. And so that's where we've sort of starting the journey. Although we've been working at this for 5 years, really the journey has only really started this year for us. So thank you for listening.